This is the third practice test that you've been doing at home. Although it's your third test, it will be numbered 9, but it's the third one. And hopefully you might have tried to do all of this test within the hour just to see how you get on. But if you took longer than the hour, don't worry about that at this stage. It's still very early days. Or if you got it finished very quickly within the hour, again, don't worry too much about that. That's why we practice and practice over the weeks and the months until the real test, and we get the timing sorted out. This test is a wee bit different from the other ones in that it starts off with maths, and the first half is all maths, and then the second half is all English. The real tests aren't like that. They're a mixture of maths and English the whole way through. But again, don't let that put you off because this is just for practice. But we're ready to go over the answers now, so let's get started. You can see here on questions 1 to 2, it asks us to write 3,105 as a number. And then we have to write 9 hundreds, 12 tens and 7 units. And what do they make? So if you think about that, I'll do that one on the whiteboard. I like to set it out as thousands, hundreds, tens and units. And it's telling us we have 3,000, so you can put 3 in under the thousands. It's all about place value. We have 100, so 1 in the 100, and we have 5, so that would be 5 units. Now you see there's a gap in the tens, so if there's a gap there, you fill the gap up with a naught, and that's what your answer would have been, 3,105. And then the same again with the next one. It tells us we have, we'll do thousands, hundreds, tens and units. We have 9 hundreds, we'll put 9 in the hundreds. We have 12 tens. So 12 tens would go 1 in the 100, 2 in the tens, like that. That's how you write 12 tens, because you can't fit 12. You can't put 2 digits under the tens, so you have to move that one up into the hundreds. And then we have 7 units. So if you put those all together, you have a 7 in the units, 2 in the tens, 9 and 1 makes 10, so almost do it like an adding, and now you have 1 in the thousands. So that answer ended up to be 1,027. And I'll write those in for you. Oh, I'll write those in on the test paper. That one was 3,105, and this one was 1,027. And then the next one, number 3, is a pie graph, a pie chart all about crimes in 1989. And you can see at it, theft as a crime. Theft was the biggest, with burglary, criminal damage, some other crimes, violent crime, fraud and forgery. And there were 5.2 million offences. And what percentage of crimes were not thefts or burglaries? And look at that not. Not is written in bold type, and that's there to get you to pay attention to it, so don't ignore that. So if we think the whole thing is 100%, if you added them all up, you would get 100%. And what percentage were not thefts or burglaries? And where are we here? So thefts were 47% and burglaries were 27%. So you're going to have to put those together, 47% and 27%. So that's thefts and burglaries together. And that ends up as 74%. But it's what was not thefts and burglaries, so it's everything else except that. So then you have to have your 100% take away 74. And you can't do that. Nothing take away 4 you can't do. Over there you can't borrow one from there. Go right over to these. Bring 1 over there. You were left with naught. Now you can bring 1 over into the units. You're left with 9 in there. 10 take away 4 is 6. 9 take away 7 is 2. So the answer was 26% was not thefts or burglaries. 26%. If you are unsure about subtraction, taking away by crossing out and bringing a 10 over or bringing 100 over, Go to your PMP book, it'll revise that for you. If you like, go on to Corbett Maths website and he will explain subtraction for you and give you examples to do. This question says, this machine multiplies a number by 5 and adds 2. So let's say 2 went in, you multiply that by 5, which is 10, add 2 makes 12, so 12 comes out. So if 17 comes out, what number was put in? And this is a working backwards sum. And I'll write on here. So if 17 came out, we're working backwards now. So instead of adding 2, we take away 2, so that leaves us with 15. And instead of multiplying by 5, we divide by 5, and that leaves us with 3. 15 divided by 5 is 3. So 3 is the number that came out. And that's a question that you can easily check, because if you now start with 3, multiplied by 5, which is 15, add 2, 17 comes out, and then you know you're right because that's the number you started with. So it checks it for you. Now, use the rule to fill in the next 2 numbers in this pattern. So the rule is, to get the next number, add the previous 2 numbers together and divide by 2. So we've got all these numbers already. So these we need, the first number we need is this one. So if you add the previous, and if you don't know what previous means, that just means the ones before. Add 6 and 8, you get 14. And then we have to divide that by 2, so that gives us 7. And now we add these 2 numbers. These will be, the 7 and 8 will be previous to this one. 7 and 8 is 15. Now when you divide that by 2, you don't get a nice round whole number. That will end up as, you can have 7.5 or 7.5. Either of those 2 answers will be correct. And then number 7. And this is a symmetry question. Shade in the squares to show the reflection of this shape on the grid. Now look at that. That's not a straightforward horizontal or vertical line. That's a diagonal line. So it's harder maybe to imagine where it would be. So at this stage when you're practicing, it's useful if you can cut out. I've cut out a little shape. And if you look at the points that are actually touching that line, that's the mirror line. It has to get reflected, flipped over. That point and that point stay where they are on the line. All the rest gets flipped over on the diagonal. They get flipped over like that. And remember, those 2 points, where are we now? Stay in the same place. So that's what it looks like. Your X would go on around like that, if you can make that out. So while you're practicing, it's okay to cut out the little shapes and try them out. If you look, it wasn't reflected vertically like that, and it wasn't reflected on the horizontal down like that. It was along that diagonal line, and that's what makes it a wee bit trickier. So it goes from there, flips over to there. If you look from there, it gets flipped over to there. Now we're on page 3, and this is a question on scale. And it says, on a scale, this line here stands for 80 kilometres. So that's your 80 there, from 0 to 80, and it's divided into 4 bits. So if you had 80 divided by 4, that's 20. So I know each little bit is worth 20 kilometres. So same with this. So what distance does this represent? And I know each little one is 20, 40, 60, 80, 100. 120, 140, 160, 180. So that is 180 kilometres. That's how you work that one out. And now we have a bar graph. This bar chart shows how far a class of pupils can swim. But look us. On this axis, we've got the number of pupils going from 0, which would be no pupils right down here, up to 7. And along this one, we've got them in groups. The distance, the distances that the children can swim. So it goes from 0 to 24 metres, and from 25 to 49, and so on. So how many pupils can swim 150 metres or more? 150 or more. So there's where 150 starts. So we need that bar and the one next to it. Everybody that swims more than 150. And then this bar, 3 can swim that distance, 1 person can swim that distance, so altogether 4 pupils swim 150 metres or more. And how many pupils cannot swim 50 metres? Cannot. So there's where the 50 starts. So you're looking for the number of pupils up to 50 metres. So again, this bar, there's 2 pupils, and this bar, there's 1. So altogether, 3 pupils cannot swim 50 metres. Now we're on page 4. And this questions 11 and 12 is all just about dividing and long multiplication. If you're having trouble with division or long multiplication, again, go back to your PMP book or go on to Corbett Mavs, and they will give you lots more practice on this and explanations how to do it if you don't get it at this stage. So 576 tins of the same size are packed in 8 boxes, and each box is the same size. So how many tins are packed in each box? So if we take all 576 tins and divide those into the 8 boxes, that'll tell us how many boxes we need. 8 goes into 57. Well, I think of your 8 times tables. 7 8s are 56, so I know that will go in 7 times, and there'll be 1 left over, so carry that over. And 8 into 16 goes 2. So altogether we'll need 72 boxes. Now, a machine stamps the use by date on 675 tins every hour. So how many tins does it stamp in 14 hours? And that's just straightforward long multiplication. So you have to take your 675 tins and multiply it by 14 hours. Long multiplication. So we start off multiplying by 4 units. 4 5s are 20, put down your notes, carry your 2. 4 7s are 28, add on 2 is 30, down your notes, carry 3. And 4 6s are 24, add 3 is 27. But we're not there yet. We now have to multiply by this 110. So you must put down your 0. And then you say 1 5s are 5, 1 7s are 7, 1 6s are 6. And then you add those 2 lines together. Your units multiplying and your tens multiplying. Nothing, nothing's nothing. Nothing, 5 is 5, 7 7 is 14, down 4 carry 1, 6 and 1 is 7, add 2 is 9. So altogether, that machine will stamp 9,450 tins in 14 hours. And in a sale, everything is reduced by 10%. And if you think about it, 10% is 10%, that's the same as 10 out of 100. Or if you wanted to say that's a fraction, that's 1/10. And to find 1/10, you divide by 10. That's all you need to know about 10%. 10% is dividing by 10. So how much would I save on a model kit which usually costs £4? And we have to give your answer in pence here. So it normally costs £4. So if I change £4 all into pence, that will be 400p. And I need 10% of that. So that's just the same as 40 divided by 10, which leaves me with 40p. 400 divided by 10 leaves you with 40. So you're going to save 40 pence. And then in this question, how much would I pay for a computer game which usually costs £30? So again, you have to find 10% of £30. And this time the answer is in pounds, so you can leave that as pounds. 30 divided by 10 is 3. So if you have 30, take away 3, that's going to leave you with 27. So the new price in the sale will be £27. And now this question, Mark, John, Claire and Kate, this is all their ages in years and months, and you have to find the average of these 4. Sometimes it'll say mean. In a question, it might say what is the mean or average age of these 4 children in years and months. So to find the average, you add them all up and divide by the number of people that you have. So we're going to have to divide by 4 because we have 4 people. And for this question, it's just as easy to keep the years and the months separate. If we added up all the years, 10, 20, we've got 40 years. If we add up all the months, 5 and 3 is 8, 8 and 8 is 16. we have 16 months, and that's years. Now we have to divide those by 4. So it's easy. 40 divided by 4 is 10, and 16 divided by 4 is 4. So the average turns out to be 10 years and 4 months. You could have maybe turned them all into months and divided them and then turned it back into years and months, but it works as just as easy as taking them as 2 separates, adding them up and dividing both columns by 4. Now on page 5, I think we are. What fraction of this circle is shaded? First of all, count how many little bits has it been divided into altogether. There were 6 bits altogether, and then how many of those were shaded? 5 of them. So that's your answer, 5/6. You can't make that any more simple. That's it. Now you have to shade this shape, the same fraction you have to shade 5/6 of this. But it's not divided into 6, it's divided into 12ths. So we have to find 5/6 is the same as how many 12ths? Because you see there's 12 little squares. So your 6, you times that by 2 to make it 12. So you have to times that, your 5 by 2, your numerator by 2 to make that 10. So you're now going to have to shade in 10. Of those, and any 10 at all, that will still show you 10 12ths or 5/6 of that shape has been shaded. And question number 18, a rope was 50 metres long, and when it's used the rope stretched by 10%. So there's our 10% again, we know that is a tenth. So we have to find a tenth of 50. That's just 50 divided by 10 is 5. You see the way I scribble and write things on the test? You feel free to do that. As you work things out or think about them, you can underline and write anything that's going to help you. So every time this rope is used, it gets stretched by an extra 5 metres. So on top of the 50 metres, it's getting stretched another 5. So that will be 50 metres plus 5 metres, which will give us 55 metres. Now, question 19. This is about volume. So we have a little cuboid here and a larger cuboid, and it's given us all the dimensions, all the measurements of the little cuboid. And how many small boxes, these small ones, will fit inside the large ones. So if you look at it along the front here, this is 16 centimetres, and along the front of this one's 4. So I will get 4 of those slotted in here. That could be 4 centimetres, 4 centimetres, 4 centimetres, and 4 centimetres. Now along here 7, and the same here 7. So you're only going to get 1 in lengthways, but up this dimension we have, I'll draw another line along there, 5 centimetres, but this one is 10. So I could get 2 little boxes in there. Now can I draw that? 3-dimensional, goes down. That one goes up to about there. So you will get, and you'll get another one in on top of that. So you get 4 along the bottom and another 4 on top of that. So altogether that would be 8 small boxes. And for number 20, what is the volume of the small box? So volume, the volume of it, that's the same as V equals the length multiplied by the width or the breadth and times the height of it. So we have, you could have 7 times 5 times 4. 7 5s are 35 times 4, that's 140. And don't be afraid if you want to do the sum out like that. But you can multiply those in any order. You could do 5 times 4 times 7. And that would be 20 times 7, which would be 140. You could do 4 times 7 times 5, and that would be 28 times 5, which will give you 140. Whatever way you do it, whatever direction, you'll always end up with the same answer. But the answer was 140 centimetre cubes. And we're on page 7, still on the maths, and it's just asking us to write this fraction as a percentage. 3/4. If you could learn that off by heart and know that 3/4 is always 75%, you might know that already. But if you didn't, think 1/4, that's 25%. And then if you had 3 of those, that makes 75%. But that's something that's useful if you can remember that. 3/4 is always 75%. And then numbers 22 and 23. What is the size of angle F? And this question is all about knowing how many degrees are in a straight line. So we're looking at angle F here, and we know that this is 130. But if you looked at the whole angle, from there right round to there, that's a straight line. All along there is a straight line. So altogether that's 180 degrees. We know there's 130 of them. So what's left is F. So F turns out to be 50 degrees. 180 minus 130 degrees gives you that. And then angle G. Well, that's just telling you that it's directly opposite this one. It's where the two lines meet. It's directly opposite. It's going to be equal. So G is 130 degrees. And that one wasn't too difficult. Not much to work out there. Nice question now on page 8. This net has shapes drawn on only one side of it. The net is folded so that the shapes are on the outside. Which pyramid can be made from it? I find these questions hard to see when you don't have the little pyramid in front of you, when it's just drawn on the page. I find it very hard to imagine what it really looks like. So I was thinking, with this shape here, there's the black circle and there's the black triangle, and if you folded those up, would it not be there? The triangle with the circle beside it. But it might not be. So that's why when we're doing the practicing, it's okay for you to draw it out and try and fold it. So I drew this one out and we'll have a look at it. If we look at the first one, fold it up. I'll fold it so that we have the white triangle, or the white circle on the right hand side. And if you do that, then you see you have the black triangle, so it's not that first one. Now, the next one then we have the black circle over on the left hand side. So that means the next, on real life, in the folded up shape, we'd have the black triangle to the right of it. So it's not that one. And the next one then, if we have the black triangle on that face, it would leave the white circle over to the right of it, so it's not that one. And if we went for this one with the white circle on the right hand face, that means we'd end up with the black triangle to the left of it, so it's not that one. So it must be the left one, the last one. But just double check. Let's go and have a look at it. We have the white triangle on the right and the black triangle on the left. So that's the only one. Now it's hard. You might find that difficult to imagine what this shape would be like when it's all folded up. So that's why it's useful, if you can take the time, do it out for real. And that's what you'll end up with. And if you actually do it and fold it yourself, you'll remember it better. It's easier to remember. And now the next one, we're just putting numbers in instead of letters. So they're starting, they've given us what each letter is worth. U is 12, A is 3, and T is 5. So we have to find what V is. So if you just write it out and V equals U plus AT, and just put the letters in below. So we don't know what V is yet, we're working that out, but it equals U. So U is 12 plus AT. Now, if it's not telling you to add them or take them away or divide them or what, if there's no mathematical sign in between, it means you multiply them. So that is A times T. And A is 3 and T is 5, so that's 15. So with 12 add 15, V equals 12 add 15, which is 27. And now this one we have to find U. So we'll put the numbers in place. V is 39, so again we've got V equals U plus AT. So we know V is 39 equals U plus, this time A is 4 times 7 U plus 4 times 7 is 28. Now 39 equals what? Add 28. So you could have 39 take away 28. And that leaves you with 9 take away this 1, 3 take away 2 is 1. So U equals 11. And we'll do more. It might be early days for you doing questions like that, but we do lots more and you'll have lots of practice of those. Now, page 9. Question 27. Each bag of plastic counters contains 144 counters, and a primary school orders 24 bags of counters. So how many counters do they get all together? This is a straightforward long multiplication. It's going to be your 144 counters times the 24 bags. And just do it long multiplication. Again, if you're rusty with this or you're unsure, go back to your PMP books or look for examples on Corbett Maths. But we'll multiply by 4 units first. 144 times 4. 4 fours are 16, down your 6, carry 1. 4 fours are 16 and 1 is 17, down your 7, carry 1. 4 ones are 4 and 1 is 5. Now we have to multiply by 2 tens, so put down your 0. 2 fours are 8, 2 times 4 is 8, 2 times 1 is 2. And make sure you have aligned your digits, that there's none overlapping so you can clearly add them. 6 add 0 is 6, 7 add 8 is 15, 8 add 1 is 9, add 5 is 14, and 2 and 1 is 3. So altogether, that school has ordered 3,456 counters. Now one of the bags of counters is divided equally among 8 children. So it's a nice straightforward dividing. We have our 144 counters divided out amongst 8 children. 8 goes into 14, it'll only go once, and it'll leave you with 6 left over. 8 into 64 goes 8 times, so each child is going to get 18 counters each. Now, if A is 1, B is 2, C is 3, D is 4, and E is 7, which of these gives 14 as the answer? And the best thing to do, you might be a bit fed up, and you might not want to take the time, but work each of them out. Because you might think you know the answer, but just work it out, and then you'll have something to double check at the end as well. So remember, if D is 4, and C is 3, and B is 2, remember the rule, you do what's inside the brackets first, so that'll make that 3 and 2 is 5. And then remember, if there is no sign, we've only got brackets, so it's 4 times 5. 4 times 5. So that's 20. So that's definitely not 14. The next one is AD. So if remember, A is 1, and if there's no sign, you times. D is 7. 1 times 7. That's 7, so it's not that one. And then we have B, and then bracket C plus D. So B is 2, and then inside C plus D is 3 plus 4 is 7. And then remember, if there's no sign, that's 2 times 7. That's 14. So I think that's the right answer. That's giving me the answer they're looking for. But don't leave out this one. Do this one just in case it might be 14 as well. And work it out. So C, D, E, that's C times D times E. So it's 3 times 4 times 7. It doesn't really matter what order you do them in. 3 fours are 12 times 7 is 84. So that's definitely not 14. So once you're sure that you've worked them all out, you find that's the third one. Number 31 is the right answer. And you get 4 marks because you get a mark for working each of those out in this particular test. You get a mark for working them each of them out, so that's why it's a good idea to have all your working out there. Do all your working out, scribble it down. Don't try and keep it all in your page 10. Here are the first 2 patterns in the series. And we have shaded squares all around a square of white squares. And it's asking us, how many black squares are there in the third pattern? You may make a drawing if you need to. And again, that's perfectly right. If you have time, you draw it out to be sure to look at it. But if we look at it, the shaded ones, we've 12 in this one. We've got 16 in this one. it looks as if we're adding on 4 each time. So if you added on 4 to this one, the next pattern along, pattern 3, would have 20 black squares. At the start of the holiday, the mileometer in the car read 00867. At the end of the holiday it read 01235. How many miles did the car travel on the holiday? And that's just to take away some. We have to find the difference between the end of the holiday and the beginning. So if you're doing difference, which means take away, you have to take away. You can write them all. Write the zeros in if you want. 0, 1, 2, 3, 5. Take away the smaller distance at the start. 00867. And that's just subtraction. And again, if you forget how to do that, if you're rusty, look over your PMP books for practice and Corbett maths. 5 take away 7 you can't do, so we'll take these 3 tens, 1 will come over and we're left with 2. 15 take away 7 is 8. Now it's 2 take away 6, we can't do that, so these 2 hundreds are helpful, 1 will come over and we're left with 1. So now we have 12 take away 6 is 6. 1 take away 8, can't do that, so this 1000 will come over and then we're left with none. 11 take away 8 is 3. And then we've nothing take away nothing, nothing take away nothing. So altogether they did 368 miles on their journey, on their holiday. If you put those 2 zeros in front, that's all right as well. That will not make any difference to your answer. And then question 35, during another holiday, the car travelled 552 miles. It travelled 8 miles on 1 litre of petrol. So how many litres of petrol were used? So we have to take our 552 miles it went all together and divide that by 8. And that will tell us how many litres it used all together. So 8 into 5 won't go, so we can look at 55. 8 into 55 will go 6 times, because 6 eighths are 48. If I tried 7 eighths are 56, that's too big. I've only got 55, so it'll have to go this 6 times, and then I'll have a remainder of 7. And that now leaves me 72. And 8 goes into 72 exactly 9 times. So the family used 69 litres of petrol. At page 11, question 36 and 37. Kay has 658 stamps in her stamp collection, and Ben has 745 stamps in his stamp collection. How many stamps do they have all together? And hopefully you'll get that one, which is pretty straightforward. 658, add on the 745, and if you add them all together, that gives you 1,403 stamps all together. Fill in the missing number. Ben has how many more stamps than Kay? Let's find the difference between Ben's stamps and Kay's stamps. So who has the most stamps? That will be the 745, and we take away, to find the difference, we will take the smaller one away from the bigger one, 658. So 5 take away 8 I can't do. Those 4 tens are helpful. 1 comes over and I'm left with 3. 15 take away 8 is 7. 3 take away 5 I can't do. So those 700s are useful. 1 comes over and I'm left with 6. 13 take away 5 is 8. And 6 take away 6 is nothing. So he has 87 more stamps than Kay has. And now we come to a bar graph, a bar chart. It shows 10 pin bowling scores of a class of children from a school. And when you get a bar chart like this, it's useful to write on the numbers of children on each bar, and then it helps your calculations maybe go a wee bit quicker. So if we look in this first band here, 40 to 49, there was 4 of them. This band, there was 12 children. This band had 8 children. This band had 5. This band had 2. They had 3, they had none in there, and there was 1. So now, we can maybe do these a wee bit quicker now. How many children scored 80 or more? So there's 80, and it's anybody 80 or more. That's right up to 119. So we've got 2 and 3, none there, and 1. So altogether that was 6. And how many children went 10-pin bowling? So that's all these bars added up all together. 4 add 12 add 16 is 24, 29, 31, 31, 34, 35. 35 children went all together. And again, double check it. If you have time at the end, that's the thing you can do afterwards. Go back and do that adding up. You may find you've made a mistake when you were rushing to get through it. And this is a sequence now of numbers complete the pattern with a 1, a blank, a 9, a 16, a 25. As we practice more, you'll begin to recognize those numbers. We do lots of work on these, but these are all square numbers. That's the answer to 1 times 1. This will be 2 times 2. This one is 3 times 3, 4 times 4, 5 times 5. This will be 6 times 6, and this one will be 7 times 7. So 1 times 1 is 1. 2 times 2, 2 2s are 4, goes in there. We're up to here. 6 6s, 6 times 6 is 36, and 7 times 7 is 49. Again, I think you had to get all of those right for 1 mark. Don't worry too much about the marks at this stage. Again, it's just for practice. But you will recognise that these are all square numbers as the weeks go on. And now finally we've moved on to the English section. All the maths is behind us for now. And this is a story about clever hands. And hands is the name. It's not those things at the end of your arms that hold your pencil or you do things with. This is hands, the name hands. It's important you read everything, the title and everything in it. And remember, I've done this before. I will read through this for you because there may be words in it that you didn't understand or words you didn't recognise when you were reading it. And maybe this will help you understand. When you hear them now, you'll know what they are and it'll help you understand it a bit better. The scientific committee investigating the amazing powers of Clever Hans the horse have failed to disprove his owner's claims that the animal is a mathematical genius. He can tap out the answer to arithmetical problems with his hooves, using 1 foot for tens and the other for units. One member of the committee said, "This horse is unbelievable. Not only does he give the correct answers to additions and subtractions, he can even convert decimals to fractions." Another scientist said, "We can find no evidence of trickery. Hans can answer whether the question is asked verbally or written on a card. I suspected that his owner had taught him to stop tapping when he gave a signal of some kind, but that can't be the case since Hans still got the answers right, even when his owner wasn't present." The unanimous conclusion after the first day of tests was that the horse displays astonishing abilities. It would seem that Clever Hans the horse really can count. Now, where did this writing originally appear? A novel, a newspaper, a comic, or an encyclopedia? And the best answer would be a newspaper. And then the next question, which 3 adjectives describe the remarkable nature of Clever Hans's ability? So if we go through them, we'll look for adjectives. He was amazing. You can write that one in. Now, if you are copying a word from here down to here, you have to spell it exactly. You can't make mistakes. The spelling has to be spot on. So take your time. And that's another thing that you can check if you have time at the end. Go back and double check your spelling. He was also unbelievable. And he has astonishing abilities. And that's those 3, and you had to get all 3 adjectives to get them out. Page 13. Based on what you have read, and that's really important, not what you think you know about horses or what you know about maths and animals doing tricks, but just on what you have read in the previous page, you have to decide which of these statements are fact or opinion. So let's have a look. Clever Hans is a mathematical genius. Well, that's someone's opinion. Another person might say he's not really very good at maths. He uses one foot for tens and the other for units. Well, that's a fact. He definitely does that. People saw him do it. This horse is unbelievable. That's an opinion. No evidence of trickery was found. That's what the committee said. That's what they stated. They found no evidence of trickery. He can answer questions written on a card. That is a fact. And Hans the horse really can count. Well, that's someone's opinion. Now, using the evidence in the passage, indicate whether these are true or false. So Hans can convert decimals to fractions. That was telling us it was true. They said he could do that. Someone was giving Hans clues, and that's false. It said they thought his owner might have been, but he still got them right even when the owner wasn't there. So that's false. And now we have a little bit more reading, so it's important you read all of this bit as well. In tests the following day, it was discovered that Hans could not answer when no one else in the room knew the correct answer. In fact, he had been responding to very small, unconscious movements which people made when he reached the correct number, and their attention was released. So, using this new evidence that we've just read, indicate whether these are true or false now. Hans can convert decimals to fractions. He can't really, because he couldn't do it all on his own. Someone was giving Hans clues, and that is true. They weren't tricking him, they weren't being deceitful. It's the people in the audience who were giving him clues, but they didn't know they were doing it. He was just picking up on their attention. Page 14. I'm going to read this story for you too. When Hollow had disappeared, Gonch had edged forward to peer into the hole. The whole roof seemed to have caved in, and Hollow was lying among the debris. Gonch had called out to him over and over, but had got no response. Just as he was starting to panic, starting to worry that Hollow was seriously injured or even dead, Hollow's arm moved. The wave of relief that swept over Gonch felt as warm as sunshine. "Hollow," he called out for about the 100th time. "Hollow, are you all right?" "Oh," was the only response. "Hollow, speak to me. Are you all right?" "Oh, yeah," Hollow moaned. "I'm great. Never felt better." Gonch grinned. Hollow was all right. The passage tells us how Gonch's feelings changed from worry to relief. Use these words, the two words, to fill in the gaps in the sentences below. But both words should end in ed. So we're changing them from the present tense into the past tense. So the worry became worried, but you have to spell it exactly right. If you put a Y in there, that's going to be wrong. You won't get the mark for it. And then relief changes to relieved. V-E-D, relieved. And again, your spelling has to be absolutely 100% correct. And in question 15, what was the first thing that changed the way Gonch felt? And I advise you to read every single one of them, because some of them might be nearly right or sound right, but don't take too soon until you've read over all of them and you're absolutely certain. Hollow disappeared. The roof caved in. He got no response to his calls. Hollow moved his arm. Gonch grinned. And again it says, underline your answer, so you have to underline that one. It was when Hollow moved his arm that Gonch felt the relief. Now the next part of the story is given below, but the punctuation has been left out. Using the exact words given, rewrite the section putting in all the punctuation. Write carefully, make your marks clear. And the passage is, what happened? Hollow asked as he opened his eyes. You fell through the roof, Gonch told him. Now the way the punctuation goes, you need speech marks around what happened and you fell through the roof. So there'll be one mark for those speech marks and one mark if you got those speech marks. You've also got the two names Hollow and Gonch. So if you've got a capital letter for Hollow and a capital letter for Gonch, that's a mark for each of those. And then you've the other punctuation. What happened? A question mark goes inside those speech marks. So there'll be question mark for that, and the other one then would be a comma there and the full stop at the end, so maybe a mark for both of those. And that's all together, you get 6 marks for that. So that's the way that would have been broken up. So see how many you get out of that. You may be able to get 1 or 2 at this stage. Right, we're nearly there. This is the last passage to read now for the English. Voyages around the world. In the 15th century, most people still thought that the world was flat, but an Italian, Christopher Columbus, believed that it was round and set out in 1492 to sail around it. When he eventually came to land, he believed he had succeeded in finding Asia, but in fact he had discovered an unknown continent, America. 2 of Columbus's compatriots also sailed westwards and explored parts of America. John Cabot in 1497 and Amerigo Vespucci, I can't speak Italian, 2 years later. The first successful voyage around the world set out in 1519 under the command of Ferdinand Magellan from Portugal. This achievement was not repeated until Sir Francis Drake became the first Englishman to circle the globe, having set out in 1577. There's loads of information in that, so we have to complete this table using the information in the passage. So we have to tell what the name of the explorer, their nationality, the date of the voyage, and if they were successful. So let's have a look. John Cabot was an Italian, and he set out in 1497, but he wasn't successful. And then the next one with him, it was Amerigo. And where was it? Amerigo Vespucci. He was also Italian. He set out in 1519 and he wasn't successful. Then after him we had Ferdinand Magellan. And your spelling has to be correct. He was Portuguese. And he set out in 1519. I think, I don't know, he was 1519, what was it? Oh, it was that one there, I've got that one wrong. If we look, he set out 2 years later than that, so that would have been 1497. 2 years later would have been 1499, wouldn't it? So that should be 1499 in there. And this boy, Ferdinand, he was successful. And then the last one to go was Sir Francis Drake. He was English. He set out in 1577 and he was successful. Now, there were 4 lines that you completed, so you get 1 mark for each of those that you get fully correct. Okay, number 26. What is one advantage of using the table to give the information? It gives the facts are clear, or they're easy to read or understand, and along those lines. You don't have too much reading to go through. And what's the advantage of using the passage? Well, if you read the passage as well, you learn more facts, more information, or facts. It tells you more about the people that sailed. Learn more, or you get fuller information. And the last page now, this is a spelling question, and there's 1 mark for each that you get right. This is very typical of things that come up on the transfer, on the AQE test. So you have to put in the correct ending, either ence or ants. So the boy came to the entrance of the cave. On the floor and walls he saw a horrible sticky substance. And all the evidence told him it would not be wise to go in. Evidence, E-N-C-E. And again, there's 1 mark for each of those. That gives you a total of 3. So that's the end of your 3rd practice test. Hopefully you got it on all right. And maybe things are becoming more familiar to you now and you're just getting a wee bit better at answering the questions. And for the 4th one, try and give yourself an hour and give yourself the whole hour. Don't rush through it. Divide it up into 15-minute sections and just try and get a quarter of the test done inside every 15 minutes. And another top tip is write everything you're thinking, write down. Write down all you're working out. Try out your spelling, draw out little diagrams, because the more you put down, the easier it is to go back over and check it. But good luck, and I hope you're getting more confident.